Okay, right now I want to go over the second problem right there on the screen. And the question says, a small bubble rises from the bottom of a lake where the temperature and pressure are 4 degrees Celsius and 3 atmospheres to the water surface, where the temperature is 25 degrees Celsius and the pressure is 0.95 atmospheres. Calculate the final volume of the bubble if the initial volume is 2.1 milliliters. So I already wrote down some of the given. Where are some of the givens? Well, it says at the bottom of the lake, the temperature and pressure are 4 degrees and 3 atmospheres. So I put T1, 4 degrees Celsius, and P1, 3 atmospheres. I did change Celsius into kelvins because all temperature in this chapter has to be in kelvins. So add 273. 4 plus 273 is 277 kelvins. The next thing is, well, what's the question? It says calculate the final volume. So I'm looking for V2 if the initial volume was 2.1 milliliters. Okay. Oh, I skipped the second part. Where as this thing is rising, the temperature is 25 degrees Celsius or 298 kelvins and 0.95 atmospheres. So at the water surface, so T2 is 25 degrees Celsius at 273 is 298 kelvins. P2 is 0.95 atmospheres. That was given, 0.95 atmosphere. Calculate the final volume. What is V2 if the initial volume, or V1, is 2.1 milliliters? So the equation overall I have to use is the combined gas law. There are a bunch of different gas laws, and I'll be using the combined gas law, this one here, because it has two P's, two V's, two N's, two T's in it. There's something that's changing, like a before and after situation. And this is a before and after situation. The bubble was rising from the bottom of the lake, and it rises such that the pressure's changed, the temperature has changed, and the volume has changed. The question is, what is the new volume? So I have two T's, two P's, two V's. There's only one thing that I have to do in this thing, or one thing that I assume, that is N. N stands for number of moles. And so how do I know the number of moles in this thing? You don't exactly, but we're assuming that N1 equals N2. I'm assuming that N1 equals N2 here. Why do I assume that? This is a bubble as it's rising from the bottom of the lake. The only way the number of molecules, molecules related to moles, the number of molecules that would change in the bubble was if you somehow remove some of the gas out of the bubble, or you added some gas out of the bubble. And no way are you adding or removing gas out of the bubble. Yes, it increased in size. Yes, the temperature changed. Yes, the pressure changed. But you didn't remove the number of molecules from the bubble. So in other words, N1 equals N2 in this problem as well. And if N1 equals N2, they'll cancel out, crossing it out. N1 equals N2. If N1 equals N2, your overall equation then is P1 times V1 over T1 equals P2 times V2 over T2. We are, again, trying to solve for V2. That's the problem. That's the question. So mathematically, V2 is equal to, multiply both sides by T2, divide both sides by P2. That'd be multiply both sides by T2, T2, P, that's a P1, V1, over, divide both sides by P2, P2, and T1. So now I know the equation. Now I have to plug everything in. Let's see if I can fit that on this piece of paper. So T2 is 298 kelvins. P1 is 3 atmospheres. I'll try to squeeze this in. V1 is 2.1 milliliters. Okay, well, 2.1 milliliters. All over P2, which is 0.95 atmospheres, that's a 9. And T1, which is 277 kelvins. So notice Some of the units cancel out, like kelvins and kelvins, atmospheres and atmospheres. The only unit that does not cancel out in this problem is milliliters. So the volume of this thing will be whatever 298 times 3 times 2.1 divided by 0.95, and 277 is in milliliters. So what is that on a calculator? So what is that in a calculator? Well, I don't know, but I have a calculator. So again, the answer will be whatever 298 times 3 times 2.1 divided by 0.95 and 277, which I got on my calculator 7.134. This is technically 2 sig figs because of that 0.95. That rounds to 7.1 milliliters, which of course the answer was E. Okay, so that's question number 2. I'll do a separate video for number 3 because I'm having technical difficulties and I don't want to do this a billion times.